Hello everyone, welcome to the video explanation for Brian Passwater's topic 1.9 and 1.10 notes, example 4. Example 4 is asking us to sketch a picture of a rational function that has the following properties. So I've included a graph here. You can hand draw your graph as well. You just have to make sure that your graph that you draw matches the verbal description given in letter A. So we have two pieces to that. We have a hole at x equals 1, which we will deal with in a minute. Okay. And then we have this other information. As x approaches 4 from the left, f of x increases without bound. And as x approaches 4 from the right, f of x decreases without bound. That is describing a vertical asymptote at x equals 4. So the first thing that we should do on our graph is draw that asymptote. We always deal with asymptotes first when we're drawing the graph. Now our function, it says, approaches 4 from the left and goes up to infinity. So as we approach our vertical asymptote from the left side, our function goes to positive infinity. And as we approach from the other side, we decrease without bound. We go to negative infinity. So we start with that part. That gets our vertical asymptote drawn for f of x. This is the graph of f of x. So then the other part is the hole. The hole is actually very easy to deal with because once we have the vertical asymptote drawn, we simply erase the graph at x equals 1 and insert a hole. Now that picture will match that verbal description. It has a hole at x equals 1, and it has a vertical asymptote at x equals 4. The rest of it, whether it has a horizontal asymptote, a slant asymptote, oblique asymptote, none of that matters. All that matters is that we have a vertical asymptote at 4 and a hole at x equals 1. Let's do another one. So on letter B, we actually have two different holes. We have g of x has a hole at x equals negative 2 and x equals 3. And then we have a verbal description of a vertical asymptote at x equals negative 1 with an even multiplicity. Okay, and that's fairly easy for us to deal with in terms of drawing. So what we do is we put in our vertical asymptote, which is at x equals negative 1. So that's a vertical line through negative 1. And then as we approach that vertical asymptote from the left side, g of x decreases without bound, so it goes down to negative infinity. And as it approaches from the right, it decreases without bound. Something like that. Okay, now again, it doesn't really matter whether we have a slant asymptote, which would actually be fairly difficult to do in this situation, or an oblique asymptote, or a horizontal asymptote. So I generally just, when I do this, I will always just include a horizontal asymptote of 0, just so that my picture, I'm sure, looks like a rational. Now again, from there, what we do is we put in our holes. We have a hole at x equals negative 2, so we just erase our graph at negative 2 and insert a hole. And then we erase our graph at positive 3 and insert a hole. And that takes care of our graph fitting this verbal description. It has holes at negative 2 and positive 3, and it has a vertical asymptote at negative 1. That's how we do that. Thank you.